All right, today we're going to go deep, way deep, beneath the surface to explore the incredible microscopic world of your skin. We're going to uncover the hidden architects behind two amazing feats. First, how your skin heals itself after a major wound, and second, how it creates the very color that you see every single day. Let's dive right in. So, I want you to imagine this. A surgeon places a new piece of skin, a graft, onto a wound. Right now, it's basically an isolated island of tissue. For it to survive, it desperately needs a lifeline. It has to connect to the body's blood supply, and it has to do it fast. So how in the world does it build those bridges from scratch? That's the first puzzle we're going to solve. You know, this first part of our story is really a high-stakes race against the clock. For this new piece of skin to have any chance, it has to forge that connection and become a living, breathing part of the body, and there's no time to waste. Okay, so here's the bottom line. A graft's success depends entirely on something called revascularization. It's a fancy term for growing new blood vessels, a process you might have heard of called angiogenesis. If this doesn't happen, the graft just fails. It's as simple as that. But that begs the question, how do these brand new vessels even know where to grow? Well, to answer that, we need to zoom way, way in. We're about to meet the microscopic construction crew that makes it all happen. See, the magic isn't random. It all takes place within the skin's own scaffolding, a built-in framework that literally provides the blueprint for this incredible repair job. This whole construction site, it has a name. It's called the dermal extracellular matrix, or ECM for short. Now, I want you to think of it as the entire environment between the skin cells. It's this complex mesh of proteins and molecules, and it is definitely not just filler space. No, this is the stage where all the healing drama is about to unfold. And on this construction site, you've got two absolute superstars. First up is collagen. Think of collagen as the steel beams of a brand new building. It provides all the fundamental structure. And then there's fibronectin. Fibronectin is the project foreman. It lays down this sticky molecular roadmap that tells all the worker cells exactly where they need to go. Okay, so here's how it all goes down step by step. First, that collagen and fibronectin team up to create a temporary foundation. Then, the worker cells, these are called endothelial cells, they arrive on the scene and start moving along those fibronectin roadmaps. As they move, they sprout and form new pathways, building roads that eventually connect the graft to the main blood supply. And just like that, the lifeline is established. This really shows you why collagen and fibronectin are the perfect duo for this job. I mean, you might wonder about other things in the skin, right? What about keratin? Well, keratin provides strength, sure, but it's inside the cells. That's like the furniture in a house, not the frame of the house itself. And melanin, totally different department. Its job is to provide color and protect from UV light. You need the right tools for the job, and for building blood vessels, that's collagen and fibronectin, period. All right, so we've seen the skin as this incredible emergency repair crew, but that's only half the story. Now, let's look at it as a master artist, performing the equally complex, equally amazing task of creating color. Seriously, go ahead, take a look at your arm right now. See a freckle? Maybe a mole? Have you ever really stopped to wonder how your skin creates those specific, organized little patterns of pigment? Because it's not random, not at all. It's a highly sophisticated delivery system at work 24/7. And that's exactly what we're focusing on now. This elegant, microscopic partnership between two types of cells that work together in perfect harmony to distribute pigment across your skin. The key to this entire process is a tiny little thing called a melanosome. You can think of it as a microscopic package. It's the little factory where the skin's pigment, melanin, gets made and stored, all bundled up and ready for delivery. This delivery system involves another one of these incredible cellular partnerships. On one side, you have melanocytes. These are the pigment factories, just churning out those little melanosome packages. And then you have the keratinocytes. These are the most common type of skin cell you have, and they are the recipients. Their job is to take in these packages. So how does this special delivery actually happen? Well, first, the melanocyte factory produces the melanosomes. Then it extends these long, tentacle-like arms, and the tips of those arms are packed full of pigment. And here's the wild part. The keratinocyte doesn't just sit there and wait for the delivery. It actively reaches out and engulfs. It basically eats the tip of that arm to take in all that pigment. Once it's inside, it arranges those melanosomes over its own nucleus, forming a tiny little shield to protect its DNA from UV damage. I mean, isn't that just the coolest thing? It's not some passive handoff, it's an active, dynamic process. The keratinocyte literally consumes a piece of its neighbor to get the tools it needs to protect itself. It is a stunning, beautiful example of cellular cooperation. And, sometimes the best way to understand why something is right is to look at why the other options are wrong. Could the pigment just squeeze through tiny channels called gap junctions? Nope. The melanosome packages are way, way too big. Okay, well, do immune cells called macrophages handle it? Nah, their job is to clean up debris and old cells, not distribute new pigment. The key thing to remember is that this targeted act of eating the melanocyte tip, phagocytosis, is the specific, elegant solution the body came up with for this very specific task. So let's pull back and just take in the big picture for a second. From emergency blood vessel constriction to the daily artistry of creating your skin tone, our skin is run by this incredible team of unseen, unsung cellular architects. So let's meet the cast of characters one last time. You've got collagen, our structural engineer, fibronectin, the project manager, melanocytes, the pigment manufacturers, and finally the keratinocytes, our frontline defenders. Every single one plays a critical role. And really, that's what this all boils down to. Your skin isn't just some passive barrier keeping the outside out and the inside in. It is a dynamic, living ecosystem. It is a site of constant, complex, and absolutely beautiful collaboration that's happening every single second without you ever having to think about it. It really makes you wonder, doesn't it? If all this intricate, genius-level engineering is happening just to heal a cut or color a freckle, what other incredible secrets is your body keeping from you? Thanks for joining me for this one.